In this example, you have the same two resistors, but now I'm going to hook them up in parallel. And I can tell they're in parallel because everything up here is at 12 volts and everything down here is at 0. So from here to here, it's a 12 volt drop. And from here to here, it's a 12 volt drop. So they have the same voltage drop. Therefore, they are in parallel. So what do... You guys, you didn't help me. Let's make this the find. Thanks. You probably noticed that and just say, oh God, he screwed it up. Let's just let him go with it. Fine. Let's see if I ever help you out. All right, anyway. So we want to find what is the current through this resistor, what's the current through this resistor, what's the total current supplied by the battery, and then what is the total resistance of the circuit. Sometimes that is called the equivalent resistance. When you combine multiple resistors into one resistor, that's like what one resistor is equivalent to those two or more resistors. Well, that's all. And if you're watching at home, pause now and try to do it yourself. All right, so let's do part A. Well, what do we know? These are in parallel, so they have the same voltage drop. So if I gain 12 volts, I have to lose 12 volts from here to here. It's a 12 volt drop. So the voltage drop is going to be equal to the current times the resistance. Well, we know what the voltage is and we know what the resistance is. So the current is just equal to V1 over R1. Well, V1 is 12 volts. And R1 is 2 ohms, which is a volt per amp. 12 divided by 2, well, in America, that's 6. But volts divided by volts cancels, and you have 1 over amps. Reciprocate and multiply, you just get amps. So 6 amps of current flowing through resistor 1. Now, let's do resistor 2. Well, I'll just start over here. I2 is equal to V2 over R2. But V2 is the same. It's 12 volts. And this is 3 ohms, which is a volt per amp. So 12 divided by 3 is 4 amps. So I've got 6 amps flowing through this, and then I've got 4 amps flowing through that. And does it make sense? Like, this is a bigger resistor. So for the same voltage, you have less current flowing through it. It's restricting the flow of current better than this one. Well, greater. So what's the total current? Well, if I got 6 amps going here and then 4 amps going through here, how much have to go into that junction? It's got to be 10 amps, right? Okay. I think they're actually nodding their heads. They're not all asleep. All right. 6 plus 4 is 10 amps. So this is I1. Am I on screen? Oh. I1 is 6 amps. I2 is 4 amps. So the total current is 10 amps. Now let's figure out what the total resistance is. There's 2 ways to do it. I can say, well, I have the formula for resistors in parallel. So let's do that. That's 1 over 2 ohms plus 1 over 3 ohms. Now, here's what students do when we have really easy resistors like this. You try to find a common denominator in the numerator, you add the numerator, then you reciprocate, and okay. Well, you can do that, but most of the time, this is going to be like 21 ohms and 45 ohms. It's not going to be easy, so just use your calculator to do it. So here's what I'm going to do. I'm going to say 1/2. I'm going to say, 1 divided by 2. Ooh, it's 0.5. Plus, parentheses, 1 divided by 3, close parentheses, equals, and I get 0.833. So what this is equal to is 1 over 0.833. And what units are with that 0.833? Say it out loud. What units go with the 0.833? Ohms? It ain't ohms. Look, it's 1 over ohms. That's a big deal, actually. And students make this mistake a lot. They forget to reciprocate. So we got to reciprocate. So I'm just going to take that number and hit the, look, here's the reciprocal button on my calculator. Let's turn the light on, maybe get a better view of it. Right here. So I push that button, and I get 1.2. 1.2 ohms. Okay? But let's check our work. There's another way of doing this problem. I can say that using Ohm's law, the total resistance of the circuit is equal to the total voltage supplied divided by the total current supplied. So this is 12 volts divided by, well, what's my total current? 10 amps. And that's 1.2, and a volt per amp is an ohm. So that's another way of doing it. And you better get the same answer or you've done it wrong. So that's a good way to check your work, actually. So here's the whole thing. Any questions? Makes sense, right? Wait till the next one.